Welcome to the session on trigonometric identities and equations. Trigonometric identities. The objectives for this session are to know and use the relationships tan theta is identical to sine theta over cos theta and sine squared theta plus cos squared theta is identical to 1. Let's begin with the definition. A unit circle is a circle with a radius of 1 unit. The point P, labelled xy, on a unit circle is such that OP makes the angle theta with the positive x-axis, as shown. So here we have the length x, and here we have the length y. Using Pythagoras, we know that x squared plus y squared is equal to 1. And using trigonometric ratios, we know that x is equal to cos theta and y is equal to sine theta. Now, since we have that x squared plus y squared is equal to 1, we can substitute in the values for x and y in this equation to give us cos squared theta plus sine squared theta is identical to 1. We use the identity symbol instead of the equals symbol to show that this identity is true for all values of theta. Now, for all values of theta with cos theta not equal to 0, we have that tan theta is equal to y over x. Here's theta, here's y, and here's x. So substituting in y equals sine theta and x equals cos theta into this equation gives us that tan theta is equal to sine theta over cos theta. And in fact, tan theta is identical to sine theta over cos theta. Again, just as a reminder, the identity symbol shows that this identity is true for all values of theta. So we have these two key identities. Cos squared plus sine squared is identical to 1, and tan theta is identical to sine theta over cos theta. Now let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. Now we have that for all values of theta, cos squared theta plus sine squared theta is identical to 1. And therefore, since in particular this is true for all angles, we can simply replace theta by 4 theta, and the identity still holds. Now let's solve example 1b. 5 minus 5 times cos squared theta, if we factorize, is equal to 5 times 1 minus cos squared theta, as shown. And using the identity, we can rearrange it to obtain sine squared theta is equal to 1 minus cos squared theta. And so we obtain 5 minus 5 cos squared theta equals 5 sine squared theta. And now for example 1c. Let's reorganize this a little bit. The main thing we're going to look at is again 1 minus sine squared 3 theta. Of course, when we rearrange our identity, cos squared plus sine squared is identical to 1, we obtain that 1 minus sine squared is equal to cos squared. And so we substitute that as shown. And of course, square root of cos squared is just cos. We can actually simplify this a little bit more. Remember that tan is equal to sine over cos. So finally, we're left with tan 3 theta, as shown. Now let's have a go at another example. Pause the video and have a go yourself. Press play when you're ready to view the solution. So let's solve this. We're going to simplify the left-hand side because that is the side that looks a bit more complicated. Looking at the numerator, you might be able to spot that this can be factorized. So factorizing cos to the 4 minus sine to the 4 gives us cos squared minus sine squared times cos squared plus sine squared, as shown. And hopefully you should be able to recognize that cos squared plus sine squared is identical to 1. And so we have cos squared over cos squared minus sine squared over cos squared. Giving us 1 minus tan squared theta, which is of course equal to the right-hand side. And therefore we've proved the identity in example 2. Now for example 3, pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Given that cos theta is equal to minus 4 over 5 and that theta is a reflex angle, find the value of cos theta. Since cos theta is negative, it must be in the second or third quadrant. Remember that if you use your calculator to find this, it gives the incorrect result because the calculator gives results between 0 degrees and 180 degrees. However, the question specifically says that theta is a reflex angle, so it must be in the third or fourth quadrant. Let's remind ourselves of the cast diagram. In the first quadrant, sine, cos and tan are all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. Now in the first part of the solution to example 3, we stated that because cos is negative, it must be in the second or third quadrant. However, we've also been told as part of the example statement that theta is reflex, and therefore it must be in the third or fourth quadrant. So therefore we can conclude that theta is actually in the third quadrant, because this is where both these conclusions overlap, as shown. And of course the little angle is 180 degrees minus theta. Using cos squared plus sine squared is identical to 1 gives us that sine squared equals 1 minus cos squared. And of course we can substitute cos theta equals minus 4 over 5 in this equation. to give us that sine squared theta equals 3 over 5 all squared, which implies that sine theta equals plus or minus 3 over 5. Now, how do we know which of these it is? In the third quadrant, sine is negative. So therefore, we must take the negative value, and sine theta equals minus 3 over 5. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Given that sine theta equals 1 over 5 and that theta is obtuse, find the value of cos theta. Now, since theta is obtuse and has a negative cosine, it must be in the second quadrant, as shown. And of course, the little angle that you can see is 180 degrees minus theta. We're going to use the identity cos squared plus sine squared is identical to 1 to give cos squared equals 1 minus sine squared. And substituting in the value of sine theta equals 1 over 5 gives us that cos squared equals 24 over 25. And this implies that cos theta equals plus or minus square root of 24 over 5. However, in the second quadrant, cos is negative, and therefore cos theta equals minus root 24 over 5. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Given that p equals 4 cos theta and q equals 3 sine theta, show that 16p squared plus 9q squared equals 144. Rearranging gives us from one equation that cos theta equals p over 4, and from the other we have that sine theta equals q over 3. And so plugging into the identity cos squared plus sine squared is identical to 1 gives us p over 4 all squared plus q over 3 all squared is equal to 1. And so this equals p squared over 16 plus q squared over 9 equals 1. Now, since 16 times 9 is 144, we're going to multiply through by 144 to give us 9p squared plus 16q squared equals 144 as required. This brings us to the end of this session. If you have understood its contents, you should be able to know and use the relationships tan is identical to sine over cos, and sine squared plus cos squared is identical to 1. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.